All right, we got to give a shout out to Lauren here. Ella, here you go, Lauren.
I hate you for leaving me.
Whoa, ouch. That was heavy. Tristan.
Love you, Lauren.
Wow, okay. All right, great. Lauren, we miss you and hope you get better soon. Okay, here we go. Same thing as yesterday. Shh. We got more challenging equations, though. Who can tell me what's different about problem one from what we saw yesterday? What about the fraction? Yeah, it sits inside of the sine, and it's part of the angle. So we have 4 sine of 2/3 theta is equal to -2, and we divide by 4. We get sine of 2/3 theta is equal to -1/2. Well, what two things have to move in order to solve for theta? 2/3 and sine. 2/3 needs to move and sine needs to move. What do you think moves first? Sine moves first. Sine is on the outside. So if you were to plug something in for theta, you would multiply by 2/3, and then you would take the sine. So since that's the last operation in order of operations, that's what you undo first. So we got to take off the sine. We do that by setting for quadrants and inversing sine. If you inverse 1/2 on your calculator, who knows what you get? Very good, 30 degrees. So what I did is by setting that up, I just did sine inverse. That's what I just did. If I do sine inverse, sine is gone, and what remains? 2/3 theta. 2/3 theta equals, I set up two of them because I have two different angles. What's the first angle? Okay, I got 330, sure, and 210. How do I then find the angle? Multiply by 3/2. So 330 times 3 is 990. Divided by 2 is 495. And 210 times 3 is 630. Divided by 2 is 315. So if you have an angle on the inside, or a number on the inside, you got to deal with that in that way. What do you think, Jayaki? Wizardry. Okay, all right. How about number 2? This is same as problem number 8 that we didn't do yesterday. What do you think? I got a 3 in front of the theta, but what do you think it should do first? Yep. Get the cosines on the same side. 2 cosine squared of 3 theta minus cosine of 3 theta is equal to 0. Factor out a cosine. Nice job, Rach. Cosine of 3 theta times 2 cosine of theta minus 1 equals 0. So I got to find where cosine of 3 theta is equal to 0 and where cosine of theta is equal to 1/2. So do I divide by 3 or do I inverse cosine? Inverse cosine. Where's cosine equal to 0? We wrote it down yesterday, 90 degrees and 270 degrees. Cosine equal to 1/2. Quadrants. Where's cosine positive? First and fourth. Inverse 1/2 for cosine? 60. So now I've got, whoop, forgot the 3 in front of that. So I got 3 theta is equal to 60. And 3 theta is equal to 300. I forgot it. It was sitting right there the whole time. Oh, there it is, right there. Sorry. So I get theta is equal to 30 degrees, 90 degrees, 20 degrees, 100 degrees. Now, let's look at our two answers real quick and understand what we're learning about our solutions in this scenario. Notice here I got 495 and 315. Do those both sit between 0 and 360? No. And the fact is that there are more solutions than just this that sit between 0 and 360. It's very complicated to try to write problems that you guys will all figure out how those work. And so what I want you guys to do when you're doing this work is when it says find solutions that satisfy 0 to 360 and you have this number in front of theta, what I'm going to ask you guys to do is that when you first go to sine inverse or cosine inverse, that these be between 0 and 360. Whatever your final results are, I don't really care as much. I care more that when you set these up, you're between 0 and 360. Same thing here. We got 90 and 270 and 60 and 300. I care that those are between 0 and 360, and we go from there. Does that make sense? Okay. All right. So let's try problems that are more difficult. What makes problem number 3 harder than the others? Everybody looks at the square root. Square root doesn't matter. You got cosine and a sine. We got two trigonometric functions. I got to get one. Tangent, how? Okay, go Carter. Smartest person ever. Cosine of x, divide through. And we got negative root of 3 is equal to tangent of x. So yesterday I warned you about dividing through. That's if things will cancel off. Here we didn't cancel enough. We just rewrote it. Okay. So where's tangent negative? Second and fourth, very good. Inverse the root of 3 for tangent. And what do you get? 60. If you just do that with your calculator, you can come up with 60. So what are the solutions? 120 and 300. Good. Again, if you don't have those values memorized, just go to your calculator. It'll show 60, just like I did. Ooh, how about number 4? Yo. Good question. Okay, so the question is, how did I come up with 60 degrees? Again, we got our calculator. Go Gadget, Virtual TI. Go watch the movie Meru. Yeah, there you go. Come on. I go second tangent or tangent inverse, and you type in the square root of 3, and you get 60. Boom. We good? Okay, look at the next problem. Cosecant of x over 2 equals 2 sine of x over 2. Oh, no. What? Double everything. Great idea, except doubling it will not get rid of the x over 2. It would just be 2 cosecant of x over 2 equals 4 sine of x over 2. 1 over sine? What about 1 over sine? Oh, so you say that, oh, okay. Well, how about this? Let's take your idea and extend it just a little bit further. The relationship between cosecant and sine is that they're reciprocals, right? So what I'm going to do is I'm going to multiply both sides by sine of x over 2. So I multiply both sides by the reciprocal. So what do I get on the left-hand side? 1. And the right-hand side, 2 sine squared of x over 2. I think I could solve that. What do I do? So 1/2 is equal to sine squared of x over 2. Take square root. List the positive and the negative. Root of 1/2 is equal to sine of x over 2. Do I get rid of the 2 or the sine? Sine. How do I get rid of sine? Sine inverse. Where is sine positive? 1 and 2, negative in third and fourth. Okay, B-Rod, I know I got it. Sine inverse of the root of 1/2 is 45 degrees. So if I do sine inverse, what remains on that left-hand side, or right-hand side? X over 2 is left, and that's equal to 45 degrees. It's equal to 135 degrees, 225 degrees, 315 degrees. You have to multiply each one of those by 2. Turns out that 90 and 450 are coterminal. They're in the exact same position. So 270 at 630. Not quite. That might be the same as 90. Yeah. So some of those are the same. Anyway, flip it over. Yeah, redundant. They're coterminal. Okay, let's get something more challenging. Those were easy. Right? Lauren's falling asleep as she's watching videos. She's like, this is easy math. Please show me something challenging. Okay, Lauren, we're going to step it up for you. What makes problem 5 more challenging than the others? What is different and unique about it? If you can't tell what's different about it, then you don't have a chance at solving it. Sine, cosine. We already had one that had sine, cosine. That was tangent. No big deal. Subtraction. I don't care about subtraction. 2x and x. I got a double angle and a single angle. And all the other ones, we have the same types of angles. Look, if I flip it back here, you've got, 2/3 theta. You got 3 theta and 3 theta. You've got x and x. You got x over 2 and x over 2. You always have the same angles. Well, here you don't have the same angle. You got sine of 2x. So I either have to make this so it has a double angle, or I have to make this so it has a single angle. Terry's looking at her sheet. What are you looking for? Double angle formula. What's sine of 2x? Written down 500 times. There we go. Remember when we did that double angle formula assignment? You wrote down sine of 2x, cosine 2x, tangent of 2x. You started to list out these formulas. So sine of 2x becomes 2 sine of x cosine of x. Now I have the proper substitution. They're all single angles. So what should I do now to solve it? Factor out a cosine. Cosine of x times 2 sine of x minus 1 is equal to 0. Sweet. Oh, you guys are smart. Smart, smart, smart. So now I got to solve where cosine of x is equal to 0 and where 2 sine of x minus 1 is equal to 0, or where sine of x is equal to 1/2. Well, from yesterday's lesson, do you remember where cosine is equal to 0? 90 and 270. And now I got to figure out what sine is 1/2. So first and second quadrants, 30-degree angle is my reference angle. I get the angles 30 degrees and 150 degrees. Cool. You guys are rolling. You just got 2 left. Next one. Uh-oh. Yeah? Bilake? Get sine and cosine on one side. We could try that. It's not going to help us too much. It's always nice to plug in formulas, but I would have more options to plug in formulas if I had a squared, right? How would we make it a squared? Square both sides. But if we divide by cosine, we get 1 plus secant of x is equal to tangent of x. We're going to still be squaring both sides, right? Now, if we square both sides, everybody be careful because you just entered the dangerous realm of mathematics. We're going to see if you really understand what you're doing. Okay, if I have x is equal to 3, there's one solution to that equation. What is the solution to x equals 3? 3. But then you go and try to be smart, and you square both sides. You get x squared is equal to 9. And then you have x squared minus 9 is equal to 0. You have x minus 3 times x plus 3 is equal to 0. How many solutions are there? Well, there's just one solution, though. When you squared both sides, you added a solution, didn't you? So you got to be careful when you square both sides. You might add a solution. The only way to really know for sure is by checking your work at the end. So let's see what we get. Square cosine plus 1. What do you got? Cosine squared x plus 2 cosine x plus 1. Yep, because you got to FOIL out that cosine of x plus 1. Good. Equals sine squared. So I want to get rid of sine squared. I only want cosines. So what are you going to plug in for sine squared? How about 1 minus cosine squared? Can I do that? Remember that sine squared plus cosine squared is 1. So therefore, sine squared is 1 minus cosine squared. So now, if I add this negative cosine squared over, I get 2 cosine squared of x plus 2 cosine of x. What happens to the 1s? Oh, so did you have the 2 factored out? Okay, I thought you meant... So now if I factor out the cosine, I get... Actually, I'm going to factor out 2 cosine of x. And I'm left with cosine of x plus 1. Something's happening with your work. I'm not hearing it, but you need to come up with this. If you're not coming up with this, I don't think it's right. Oh, that's not true. No. Sine squared of x plus cosine squared of x is equal to 1, right? If you try to rearrange this to get a negative, it's not going to happen. If you subtract the cosine squared over sine squared of x is equal to 1 minus cosine squared of x. Subtract the sine squared over 0 equals 1 minus cosine squared minus sine squared. Subtract the 1, negative 1 equals negative cosine squared of x minus sine squared of x. So but it's a negative cosine squared, so it's not cosine squared minus sine squared. The only thing that's special about that is it's equal to cosine of 2x. Can't substitute anything for cosine minus sine squared. We can check it out if you want to. But we should not come up with that in a different assignment either. All right, so let's take these two. We'll look at it together, bud. We got 2 cosine of x is equal to 0. And we got cosine of x plus 1 is equal to 0. So if I divide by the 2, I'm wondering where's cosine of x equal to 0? We've already answered that question in a previous problem. What do we get? 90 and 270. Very good. And then cosine of x plus 1 equals 0. That's where is cosine of x equal to negative 1? 180. If people are wondering where we're coming up with those values, there comes a point where you have to memorize this idea. We have 1, 0, we have 0, 1, we have negative 1, 0, and we have 0, negative 1. So cosine is the x value. So where is x 0? X is 0 at 90 and 270. Cosine is the x value. When is x negative 1? Over at 180. That's the piece you have to come to a time where you memorize that. Keep that in your brain. All right, well, we got 3 answers, but we know that we possibly added a solution that didn't exist because we got kind of careless. We squared both sides. So let's undo the squares and plug them in and check. Cosine of 90. 0 plus 1. 1. Sine of 90. Sweet. Cosine 270. Plus 1. Sine of 270. Negative 1. Cosine of 180. Negative 1 plus 1. 0. Sine of 0. Those are my 2 solutions. Let us finish with one last problem that you've actually done 2 or 3 times already. If you've done your homework. Actually, we did this in our notes, I think, twice. I got 3 different ones here. What do you want to do? Okay. B Rodden is a good idea. Cosine of x over 1 plus sine of x over 1 times sine of x over cosine of x is equal to 2. So he's going to make this into, simplifying a trig expression. Kind of our first assignment, our first worksheet. He's going to say, well, maybe I could come up with something on the left-hand side that'll work really well. Now, what do I do the right-hand side? Or what do I do this cosine guy over here? Yeah, cosine of x over cosine of x. So I found common denominators. What is my new denominator? Cosine of x. What sits in the numerator? Cosine squared of x plus sine squared of x, which B. Rodden says is 1. Like, when you leave trig, you'll probably remember SOHCAHTOA, and you might not remember anything else. But please tell me that you remember sine squared plus cosine squared is 1. Like, just remember that thing. Like, if I'm so honored to be invited to your wedding someday, okay, all right, okay, all right, Carter, who are you going to marry? Trina, okay, all right. So, Carter and Trina are going to get married, and when you invite me to your wedding, which I don't know why, but you decided to invite me, and I show up, and I'm going through the line, and said, Carter, congratulations. By the way, what's sine squared plus cosine squared? You're going to say 1. You're going to own it. And you're going to feel proud because even on your wedding day, you remember some trig. Yeah? We good? 0, baby. All right. So, Jake from State Farm, you're saying you're gonna tell me it's tangent? Is that what you said? So you guys can't say that. Lauren, they just said that they never knew that sine squared plus cosine squared is 1. That's a lie. You guys are naughty people. 1 over cosine is 2. So now what? Secant of x is 2, or cosine of x is 1/2. However you want to write it. Okay. Well, most people saw that during first and third hour, so that's what I went with. Well, it's the same thing. You could take the reciprocal of both sides, which is what I did. Okay, so cosine is 1/2. Where is cosine positive? First and fourth. Cosine inverse 1/2. 60. Wow, you guys are smart. So x is 60 and 300. That's my solution. Sweet. You guys are amazing. That's it. Say goodbye, 7.5. I've done so much work. I've spent so much time teaching you. Now it's time for me to take a vacation the next couple days and let you go to work on your study guides and your homework, and I will help you. And even though the same question may get asked me 15 times, I will not be angry or dismayed. I'll be excited you're asking that question, and we will go over it together. Sine plus cosine. Sine plus cosine does not simplify. Sine squared plus cosine squared does. That's 1. If it's sine plus cosine, that does not simplify. It's just sine plus cosine. That's it. Good question, B. Rody. All right, here you go. There's your assignment. Make it happen. Go be great. If you do not have college trig homework this weekend, then you're either really on top of the game and doing great in math, or you're complete putz. All right? You're one of the two, right? Come on. How could you not be one of the two? Okay, Casey says I'm right. How else? How else would that work? Okay, Jake, do you have all of your homework done? No, so you're going to have homework this weekend, right? All right. There you go.